this lesson, we are going to explore how JS variables handle their values. JavaScript has two types of values, primitive value and object. Primitive value includes string, number, boolean, undefined, and null. Array, function, and object are object-type values. Primitive values are immutable. For example, if you have ABC and you want to change it to ABCD, ABC will be wiped out first, then ABCD will be created. JS Engine will not directly add D to the back of ABC, because that would make a primitive value mutable. When you assign a primitive value to a variable, the value itself will be assigned to the variable. This is called assignment by value. When you assign an object-type value to a variable, things are very different. If you have experience in low-level languages like C, you would know object-type values are stored in heap. We operate them via their memory address. When we assign them to variables, what the variable actually gets is the memory address of the object, not the object itself. This is called assignment by reference. Variables whose value is a memory address are called pointers. In the future, whenever you see the word reference or pointer, you should know it is about memory address. If you do not know any low-level language and have never thought about how our codes are handled and executed in memory, then what we just said is all you need to know. JS is a high-level language, which means pretty much all memory-related operations are done automatically. Most of the time, you don't need to worry about what happens in memory. There is a very big difference between assignment by value and assignment by reference. Let's say we declare two variables, A and B. We assign 1, 2, 3 to A and then assign A to B. When you assign one variable to another, the variable on the left side of the assignment operator will first have its value copied, and then the copied value will be saved into the variable on the right side. This mechanism stays the same no matter what kinds of value the variables store. When we assign A to B, 1, 2, 3 will be copied and the copied 1, 2, 3 will be saved into B. If we output B, we will get 1, 2, 3. If we reset B's value, say we assign 4, 5, 6 to it, then we output A and B. What do you think we will get? A will still be 1, 2, 3 and B will be 4, 5, 6. Because the two variables are independent of each other, there is no direct link between them. Resetting B will not do anything to A. Then let's try object-type value. We assign an object to A. Inside the object, we create a property ID and set its value to 1. Object-type values are assigned by reference. Therefore, A never gets the object itself. It only gets the object's memory address. When we assign B to A, we copied the memory address and put it into B. So now, both A and B point to the same object. We access the ID property using b.id and reset its value to 2. Then we output a.id. What kind of result do you think we will get? Will we get 1 or 2? We will get 2, because A and B points to the same object. We alter the object via B. A will show the changes as well. This is the biggest and also most important difference between assignment by value and assignment by reference. In this lesson, we will talk about JS scope. Scope means an area within which a variable or function is accessible. JS only has two types of scopes, global scope and function scope. If you define a variable or function at the top level of your program, then this variable or function has global scope. They are accessible in any location of your program. Top level means outside any function. If you create an outer function first and define variables and functions inside that outer function, then these variables and functions have function scope. They are only visible inside the outer function. When you define a variable or function, it will be hoisted to the top of its scope. This is called variable hoisting and function hoisting. Hoisting can bring us a surprising result. Let's say we define a global variable and then console log it. We get its values, no surprises here. But what if we move the console log to before the variable declaration and value assignment? Using an undefined variable will get you a reference error warning on console table. But the result we get here is undefined. If you only declare a variable and do not give it any value, JS will use undefined as the variable value. But here, we output the variable before its declaration. So why do we still get undefined? This is the result of variable hoisting. When JS Engine compiles our code, it will move all variable declarations to the very top of their scope. This is what our program actually looks like when it is being executed. The variable declaration is placed at the first line. Then we console log it. At the end, we assign a value to it. Naturally, we will get undefined. Functions will also be hoisted, but unlike variable, function hoisting hoists everything. If you invoke a function before its definition, the function will be executed normally. In your real-life projects, always declare variables and functions at the very top of their scope. This can make your program much easier to read and maintain. There is one more topic we need to cover: using undeclared variables. First of all, using undeclared variables is a very bad habit. You should never do it. But you should know what happens when you use them. At global, we directly assign 123 to A. Then we console log A. We get 123. So for global variables, declared variables and undeclared ones behave the same. Then let's try local variable. We create a function and name it outer. Inside outer, we assign 456 to B. Then we run the function. B is a local variable, which means it should only be visible inside outer. If we console log B at global level, we should get reference error. But this is not what we got. We successfully output B's value. This is because JS Engine will automatically regard undeclared local variable as global ones. In other words, if you create undeclared local variables, JS Engine will do the declaration for you. It will declare those local variables as global ones. Therefore, never use any undeclared variables. Always remember to declare first and use later. In this session, we're going to talk about scope chain and how JS processes unneeded data. To understand scope chain, you need to view scope from the perspective of program execution. Here comes a new concept: execution context. Execution context means the part of a program that is currently being executed. Whenever our execution context enters a new scope, JS Engine will record and create every variable and function this scope has. This list will be attached to its parent scope list. The chain of list is called scope chain. Basically, scope chain records all variables and functions that are accessible in the current execution context. Whatever your program design is, when we execute it, we will always start at global level. Therefore, the first link of a scope chain is always the global scope. Take a look at this example. We've got a global variable and a global function. Inside the global function, we've got a local variable. Then we execute the function and assign it to another global variable. If we run the program, what kind of scope chain will we get? First, the global scope will be added to the chain as the first link. Then we enter the function. The function scope will be added to the chain below the global scope as the second link. If we invoke the function again and assign it to a different variable, what would happen? Every time you invoke a function, you get a function scope. It doesn't matter if you invoke the same function or not. This is what our scope chain will look like. Under global scope, there are two identical but independent function scopes. We now have two copies of the local variable. If we invoke the function for the third time, another function scope will be attached to global scope. We will have 3 copies of local variables. Attention here, every time I invoke the function, I assign it to a global variable. The variable here works as an identifier of the function scope. What do you think will happen to the scope chain if we remove the variable? To answer this question, we need to learn a new concept: JS garbage collection. Everything you write in your program consumes memory space, which is precious and limited. Therefore, the moment something becomes unneeded, we should remove it from memory to release the memory space it occupies. For primitive type value, this is easy. You give its variable a new value. The original one will be wiped out. But for object type values, things are different. They are not stored in variable, only their memory address is. Assigning new value to the variable will only wipe out the memory address. JS is a high-end language. Pretty much all memory-related operations are done automatically and behind closed doors. If you work with low-end languages like C, you will have to allocate and release memory space manually. Even in PHP, we can delete query result object using free method. But in JS, memory release is done automatically. So if we want to remove an object type value, we need to send a signal to JS garbage collection and ask it to do the cleaning for us. So, how do we send the signal? The short answer is dereferencing that object type value. In plain English, dereferencing means remove the memory address stored in variables. This is easy. We just assign a new value to that variable. For example, we've got an object here and it is assigned to a variable, a. Now the memory address of this variable is stored in the a. If we assign a new value to this variable, then the original memory address will be wiped out. As a result, the object has been dereferenced. As a result, the object becomes unreachable, which means it is useless to us. The JS garbage collection will remove this object and release the memory space it occupies. But there is a catch here. If we assign a to variable b, then resetting a's value alone will not remove the object from memory. Because the object has not been completely dereferenced yet, we can still reach it via variable b. In other words, variable b is the straw that keeps the object alive. If we forgot to reset b, then this unneeded object will keep staying in memory and occupying memory space. This is called a memory leak. Obviously, this is a bad thing. Back to our question. If we only invoke the function but do not assign it to any variable, then the scope of the function will be removed by JS garbage collection immediately after they are created. As a result, the scope chain only consists of one link, the global scope. Remember this conclusion. It is vital for understanding how closure works. Due to historical reasons, JS doesn't have block scopes. You only have global and function scope. It is too late to redesign JS, therefore we just have to make the most of what we have. Meaning we just have to play function scope to its most. The most commonly used and important real-life application of function scope is closure and IIFE. To create a usable closure, you need 5 items, 2 functions, 2 variables, and the keyword return. First, we create a global function called outer. Then inside it, we create a local variable num and a local function inner. Then, the most important step, we return inner. We set num's value to 1. Inside the inner function, we console log num++. Console log num++ means outputting num first and then add 1 to its value. We returned the inner function inside the outer function. Therefore, invoking the outer function will get us the definition of the inner function. This means the inner function can be invoked at the global scope. Return did the magic here. Then we assign the outer function invocation to a global variable inner. Now, the global variable inner is the identifier of the returned function. Then, let's invoke inner for 3 times. What kinds of result do you think we will get? 1, 2, 3 is what you will see on your screen. When we first run the program, the global scope will be added to the scope chain as the first link. When the outer function gets invoked, the outer function scope will be added to the scope chain, right under the global scope. When we run the inner function for the first time, the inner function scope will be added to the scope chain, under the outer function scope. The inner function will retrieve num from the outer function scope. At this time, num is 1. Therefore, we will first get 1 on the console table. Then the inner function will reset num to 2. So now in the outer function scope, num is 2, not 1 anymore. Like we said before, every time you invoke a function, you will get a scope chain. So when we invoke the inner function for the second time, its new scope will also be added to below the outer function scope. The second inner function will also retrieve num from the outer function scope. At this time, num's value is 2. So, the second invocation of the inner function will log 2 on the console table. Then the second invocation of the inner function will reset num to 3. Naturally, the third invocation of the inner function will console log 3 on the console table. This is why we can get 1, 2, 3. The 3 scope of the inner function retrieves num from the same location. Because of the global variable inner, the outer function scope will stay alive in memory. This is why the second and third invocation of the inner function can access the same num. But if we do this, instead of assigning the outer function to inner, we put 2 sets of parentheses behind it. The first set of parentheses will invoke the outer function and get us the inner function's definition. The second set will invoke the returned inner function. If we invoke the inner function for 3 times this way, what do you think we will get on the console table? Remember, every time you invoke a function, you get a function scope attached to its parent scope. If you think the result is still 1, 2, 3, then you need to review this whole lesson. The result will be 1, 1, 1. Like we said before, every time you invoke a function, you get a function scope. Here, in total, we invoked the outer function for 3 times. Therefore, below the global scope, there are 3 identical but independent outer function scopes. Below each outer function scope, there is an inner function scope. Therefore, each invocation of the inner function retrieves num from its own outer function scope. This is why the result we got is 1, 1, 1, not 1, 2, 3. IIFE means Instantly Invoked Function Expression. To create an IIFE, we need 2 sets of parentheses. The first set is placed behind the last curly bracket of the function. All function argument values are provided here. The second set of parentheses wraps everything. You might have noticed we did not set a function name. This is because IIFE does not need a name, and even if you set a function name, it won't work outside the parenthesis. We will get a reference error saying there is no test function. Now we know how IIFE works, let's take a look at its real-life application. The intention of this program is to create an array. Each array element is a function which returns the element index. We create a for statement and use variable I as counter. At first glance, there seems to be nothing wrong with the program. Variable I starts at 0 and will increase by 1 with every loop. We use I as array index and return I in the anonymous function. If we invoke the first array element, we should get its index, which is 0. If we invoke the third one, we should get 2. But this is what we get on the console table. No matter which array element we invoke, we will keep getting the same result, 10, which is I's value at the end of the loop. So, why? It's because JavaScript does not have block scope. The curly brackets of the for statement is useless in terms of creating an independent scope. As a result, variable I is a global variable. The for statement will create 10 array elements. The values of the 10 array elements are the same, an anonymous function returning global variable I. At the end of the loop, i's value has been set to 10. Naturally, no matter which array element you invoke, it will always search for I from global scope. Therefore, you will always get the same value, 10. To solve this problem, we need to create an independent scope inside the for statement. IIFE can help you achieve this at the lowest cost. First, we empty the for statement. Then we install an IIFE. Now, each loop will trigger one IIFE, which means each loop will have its own scope. Inside the IIFE, we create a local variable k and assign I to it. From this moment on, k will take over. We no longer need I. We use k as array index and return it in the anonymous function. Now let's try the program again. We invoke array 0. We got 0. We invoke array 2. We got 2. With IIFE's help, we finally got what we want. The for statement will invoke 10 IIFE and create 10 scopes. Each scope has its own local variable k. This is what the scope chain looks like. Under the global scope, there are 10 sibling function scopes. Each function has its own variable k. At the end of the loop, I will still be 10, but it doesn't matter. Each array element retrieves k from its own scope. In this lesson, we are going to talk about another confusing area of JS. Keyword this. This is a reserved keyword. It exists in almost every computer language. This is a pointer. It tells you the owning object of your current execution environment. In client-side JS, every function's this points to the window object, regardless of global functions or local ones. If you are running server-side JS, which is Node.js, every function's this points to the root object. Let's prove this to you. In global scope, we directly console log this. We got window. We create a global function and console log this in it. We still get window. We create a local function and console log this in it. Still window. You can nest as many functions as you want. The result will always be the same. This in function always points to window. Next, let's try methods. We create an object literal. You can also use constructor function. The result will be the same. Inside the object literal, we create a method and console log this in it. Then we invoke it. This time, we will not get window. We will get the object owning the method. The conclusion is, for functions, this always points to window. For methods, this always points to the method's owning object. Here's a thought. What if we put a function inside a method? Where will the function's this point to? Let's find out. In the object method, we define a function and console log this in it. Then we invoke it. Let's run the method and see what we can get on the console table. We can see the function's this still points to window, even though it is defined in an object method. According to Douglas Crockford, the creator of JSON, this is a design mistake. Had JS been designed correctly, function defined in methods should have its this pointing to the method's belonging object. This makes perfect sense. For example, if the object also has a few properties and we want to access those properties in the function, using this .propertyName in the function will not work. The solution is to assign this to a variable in the method and use that variable in the function. In our previous Vue and Axios lessons, we have already tried this solution. Let's take a look at another scenario. We've got an object here. We retrieve its method and assign it to a global variable. Now, the global variable is an identifier of the method. If we invoke the global variable as a function, where will this point to? The object owning the method or window? Let's find out. We can see this still points to window. Conclusion: as long as it is a function, no matter how it is defined, this always points to window. In this lesson, we will learn 3 new methods: bind, apply, and call. We will start with bind. The most popular application of bind is to reset where this points to. By default, all functions have their this pointing to window. Using bind, we can repoint this to any location we want. The bind method will not invoke any function or method for you. It only returns a modified version of its attached function and method. You need to do the invocation yourself. Take a look at this example. We've got 3 objects here. The test function console logs it's this. Unsurprisingly, it's this points to the window object. Before we invoke the test function, we connect it to bind. Then we set the argument value of bind to an object of our choice. Then we invoke the test function. This time, this no longer points to window. It pointed to the object we chose. The most genius part of bind is the value it returns. It does not invoke the function for us, it only returns a modifier function. In async operations, we will constantly use a function as argument value. Using the bind method, we can fix the this issue without any side effects. Bind is not the only method that can repoint this. Call and apply can do the repointing as well. But unlike apply, call and apply will directly invoke the function they are attached to. The difference between call and apply is how they provide arguments values. Apply puts all argument values in an array. This array will be its second argument. The first one is of course the object you want this to point to. Call, however, does not use array. You provide those argument values directly. Be careful here. Unlike bind, apply and call will directly invoke the function they are attached to. Therefore, never use them in async callbacks functions. In this lesson, we will learn a new concept: wrapper object. In JavaScript, every primitive value has a wrapper object. The creation and destruction of a wrapper object is done by JavaScript automatically. Wrapper object offers us a convenient way to operate primitive values. For example, we've got a string here and we store it to a variable a. If we want to know the length of the string, we can use the length property. If we want to capitalize it, we can use the toUpperCase method. The wrapper object is created by JS Engine automatically. When JS Engine sees the dot, it will immediately know it is time to create the wrapper object. The lifespan of the wrapper object is extremely short. It will be immediately deleted when the next line starts to be executed. Let me prove this to you. We create a new property for a. In the next line, we output the new property. We get undefined. This means the property we just created no longer exists. This proves the wrapper object no longer exists. If you first get string length and then capitalize the whole string, then 2 wrapper objects will be created and destroyed. This may not look very economical or smart, but this is how JS handles wrapper objects.